Are Tømmerås at Migris, and this is part 4 of our instruction video series for the new MigriX lightweight petroleum systems modeling software. And in this video we'll be looking at some of the migration analysis functionality in MigriX. And here we start by looking at the model which has already been simulated and opened. So it has a number of layers, in total 12 different layers with 3 source rocks and several carrier beds, particularly the yellow layers here, which are sandstone reservoirs. And we can start by looking at the modeled migration flow rates. So here we see that it's several of the units where we see a flow and we see accumulations, and we can use the filter undefined function to hide the areas where we do not have any flow, so that we can easily focus in on the areas with active migration and look in more detail at the migration systems. We may also want to look at the picture at previous time steps. So we're going back to the 5 MA time step, which is quite similar to the present day. Can go to 24 MA time step. You see that it changes a little bit. We can go into 2D mode instead and switch between 24 and present day and see that there are quite clear differences. So this is both due to changes in the generation through time and to the topographic changes of the carrier bed. Next we may want to look at the vertical migration directions, and to do this we go to the flow direction property, and this will show the direction of the vertical flow color coded, so that the red it's upwards, yellow is lateral migration, and blue is downward migration. So we can pick one of the carrier beds and look at it. So we have a large yellow area here in the southeast with the lateral migration. So you see that corresponds with the area where we have flow. There are also some areas with both up and down migration. So if we go to another carrier, you see that it's a much larger area, which is yellow with lateral migration. And again, this corresponds to the area where we have flow rates values. We can also go and look at the permeability map for this carrier, and here we see that it's only in the area with yellow with lateral migration that we have permeabilities above 0.9 or 1 millidarcy. So we, in principle, here we see that we have only lateral migration in the areas with high permeabilities. Okay, so next we may look in more detail at some of the modeled accumulations. So we go to the traps folder and plot the closures and the modeled column heights. So this is shown in meters. We can also look at the different phases, the gas column heights and the oil column heights, which is typically thinner. We can also plot the unfilled capacity. So we see that some of the structures here are not filled to spill. We can also look at the modeled contact levels for the different accumulations. So these are shown then in meters below sea level, and typically flat contacts within each trap segment. Now we may want to look in detail at the drainage areas for one of these traps. So I pick one accumulation and go to the pick drainage option, and this will show us the local drainage area for this structure. We can also plot the layer drainage, which shows the entire possible spill area, the greater catchment area for this trap. And we can plot different properties on top, like the depth map and the depth map with the hydrocarbon pools. And we may also want to save this drainage area, the outline or the grid, to import it to a different software, or we can import it as a cultural overlay. So we go to the base maps and load it and say that we want to map this onto all horizons. And we then see we have a black outline around the drainage area, which will be shown as an overlay on all properties that we plot later. Now we may also want to look in more detail at the trap statistics for this accumulation. So we go to the trap viewer and open it, and we have just one trap active. We can look at the trapped hydrocarbons chart, which shows the filling history through time for the accumulation with the volumes of oil and gas. We can switch if we want to show only standard conditions or both standard and reservoir conditions. And we see here that it's quite large volumes for this trap, up to 2000 million cubic meters, and it's increasing through all time steps. We may also want to show the free capacity. So we see that here actually there is still some unfilled capacity at present day. We can also go to the moving hydrocarbons plot and look at how much is actually moving through the trap at the different time steps. And we see here that for this particular trap it's receiving both spilled and drain oil. And we can look at the lost hydrocarbons, and we see that it's only losses occurring at 90 MA, and it's relatively small volumes that are lost due to leakage. Next we can look at the different hydrocarbon properties, such as density and gas condensate ratios, GOR, and so on, through the different time steps. We may also look at the pressure and temperature evolution through time for this structure. And all of these results and more can be found in the trap table chart, which shows a table listing of all the different traps and time steps with the volumes and the different properties. And of course this trap can easily be exported and opened in another viewer for further processing. So this was looking at just one single trap, but we can also pick multiple traps in the filter traps map. And so we select about 10 different traps, and we can then show the summed trapped hydrocarbons for all these traps through time. And the same for the moving hydrocarbons. Okay. And this of course works also for all other properties. Next we may want to look in more detail at the modeled migration flow paths. So we start by picking some points where we want to study the migration in more detail. Go to the show streams option in the right mouse button menu, and this will add a set of streams starting from the points that we have digitized. And all these streams will be added to the project workspace, where you can go in and select them and set the properties that should be shown for these streams. So here we are plotting just the depth property as comets, and we see actually this example all the streams are merging into one single flow path. We may also set up an animation and show the stream movement. That makes it a bit easier to follow the migration routes in the model. You can switch between 2D and 3D view and look at this. We hope this video has clarified any questions you might have, and please use the contact information shown on the screen if you have any further questions. Thank you.